What we're talking about today is Lesson 63, Understanding the Unit Circle and Radian Measures. A unit circle is a circle with a radius of 1 unit. So they're showing you a circle here, and the radius r, they're saying, has a length of 1 unit. And that's what we call the unit circle. We'll show some more detail on this in just a minute. Angles can be measured in degrees or in radians. Up to this point, we've only talked about angles being measured in degrees. So what we'll talk about a little bit today is changing them to radians and using them in radians. The measure of an angle in radians is based on arc length, the distance between 2 points on a circle. Okay, so if we're talking about the distance between 2 points on a circle, we're talking about this, and then we would talk about this angle measure as being the 2 points in the distance there. In a circle with radius r, the measure of the central angle theta is 1 radian when it intercepts an arc that has a length equal to the radius. There are 360 degrees or 2 pi radians in a circle. And this is one of the questions that you had on your evaluate test the other day that you would have not had any idea about. That's just generic definition for you. 360 degrees is equal to 2 pi radians. So 1 full circle is equal to 2 pi. Okay? Thus the conversion factor 2 pi over 360, which is equivalent to 1, can be used to convert measures between degrees and radians. All angles are measured clockwise or counterclockwise from the positive x-axis. Positive x-axis is right here. Okay? That's always our starting point. Measured clockwise, they are negative angles. In the figure, the negative 210 degree angle is equivalent to an angle measure of 150 degrees. So what they're saying is from here, they went a negative 210 degrees. We know that from here to here is negative 90, and then over to here is negative 180. So they went an additional 30 degrees to get that negative 210 degrees. And it's equivalent to an angle measure of 150 because we could go from here to here, and we could say that that was 150 degrees. To convert angle measures, there are 2 formulas which are basically the same thing, it's just the reciprocal. If we're wanting to convert from degrees to radians, we use pi radians over 180 degrees. If we're wanting to convert radians to degrees, we put 180 degrees over pi radians. And the way they got this from the 2 pi over 360, because they just reduced. If you reduce by 2 on top and bottom, that leaves you with that pi over 180. And then they flip it for changing radians to degrees. So on this one, it wants us to convert each measure from degrees to radians or from radians to degrees. If you did not write those formulas down, I would back the video up and make sure I get those put down on my homework so I can find them quickly. On this one, negative 30 degrees, I'm converting from degrees to radians. So when I do that, I'm going to use the pi over 180 degrees radians. Okay? And whenever I multiply these, I would get negative 30 pi over 180. Those are both degrees. And I can reduce that. Okay, I don't want to get rid of the pi. I just want to reduce the angle measures, so they both reduce by 30, which is going to give me negative pi over 6. That's my final answer. On the other one, I'm converting from radians to degrees, so I'm going to use that same formula, but I'm going to flip it instead. So I have 3 pi over 4, and to change from degrees to radians, and it's radians, I guess I should label. And this one should have been labeled radians. To convert from radians to degrees, I'm going to put that 180 on top this time over my pi radians. Okay. So whenever I multiply here, I'm going to cancel pi with pi, radians with radians, and then I can just multiply across. So I have 3 times 180 degrees over that 4. And 3 times 180 gets me 540. Should have done that. 540 over 4. So I'm just going to divide now. When I do that, I get 135 degrees, and that's my final answer. For every point P, which is x, y, that's the ordered pair, on a unit circle, the value of r is 1. Therefore, if theta is an angle in standard position whose terminal side passes through point xy on the unit circle, then you need to write this part down. Sine of theta is equal to y over r, which is, since we're talking about unit circle, it's just y. Cosine of theta is equal to x over r. Because we're talking about the unit circle, the r is just 1, so it's just x. And then tangent is equal to y over x. So you need to write this down. I would just find wherever this is at in your book and make a reference in my notes to that so that I could look back at it. Eventually you will get really good with the ordered pairs. It says, so the coordinates of P can be written as cosine theta, sine theta, and that's because cosine is the same as x and sine of theta is the same as y. So that's the same thing as writing. Writing it xy would be cosine theta, sine theta. The diagram shows the equivalent degree and radian measures of special angles and the corresponding x and y coordinates of points on the unit circle. So what they have here is at 0 you have 0 radians. At 30 degrees you have pi over 6 radians. Over here at 135 degrees you have 3 pi over 4 radians, and it goes all the way around. And then whenever you go out, you can see that this is the point that they're talking about. Okay, so if I were talking about the sine of 150 degrees, sine is y, so I have x, y, so the sine of 150 degrees is 1/2. Okay. Alright, so example 2 says use the unit circle to find each trigonomic function value, find exact values. So I went ahead and I put the unit circle on this slide so that you didn't have to flip through in your book. And sine of 120 is what we're talking about first. So 120 is right here, which goes with the 2 pi over 3 radians. And remember that we said that sine is the same as y, so I have x and I have y. So the sine of 120 is going to be equal to radical 3 over 2. That's all you have to do. If I'd wanted the cosine, then I would have taken the negative 1/2. Excuse me. If I'm talking about finding the tangent of 11 pi over 6, well, 11 pi over 6 is right here, and it goes with this ordered pair, which I can name x and y, I can label it. Well, we have to also remember that tangent of theta is equal to y over x, which you should have written down from the last slide. So you have to take the y value over the x value. So that is going to be that negative 1/2 over x, which is radical 3 over 2. Okay? And then from there, what I'm going to do is I need to get rid of this complex fraction that I've got going on here. So I'm going to flip this and multiply. Okay, this is the same as if I had it written as negative 1/2 divided by radical 3 over 2. You should remember that we take 1/2 times 2 over radical 3. Okay, so that's what I'm going to do right here. Flip it and multiply it. So I'm going to multiply by 2 over radical 3. 2's will cancel, so I have negative 1 over radical 3. You should also remember that we can't ever have that that radical in the denominator. We want to make sure that we always rationalize denominators, so I'm going to multiply by radical 3 over radical 3 to rationalize it, and that's going to give me negative radical 3 over 3. Okay. You can use reference angles in the portion of the unit circle in quadrant 1 to determine trigonomic functions. To find the sine, cosine, or tangent of theta, it says just determine the measure of the reference angle of theta. Then you need to use the portion of the unit circle in quadrant 1 to find the sine, cosine, or tangent of the reference angle. And then use the quadrant of the terminal side of theta in standard position to determine the sine of sine, cosine, or tangent. And doing an example will make this make a lot more sense to you. So, for example, this is what they're talking about with the terminal side. If whenever you graph your angle and it stops, say, over here, this is my terminal side, and the sine for this angle is going to be positive, the cosine will be negative, and the tangent will be negative. Okay, if my terminal side stopped over here, that's in quadrant 4, then my sine would be negative, my cosine would be positive, and my tangent would be negative. So, it says find the sine, cosine, and tangent of 135 degrees, find exact values. So I'm going to start by plotting this. So I start at my positive x, and I'm going to rotate 135 degrees, which is about here. So my reference angle is this angle right here, which I can find by taking my 180, which is over here, minus that 135, which tells me that this is 45 degrees. So what I can do is I can refer to my unit circle, and if I was on my unit circle, then I would have my point right here. And if you look back, or you have it written down, or you have your book open, that's fine, and you can see that this point would be radical 2 over 2, radical 2 over 2. So to find the sine of 135, that's supposed to be a 5. Let's write that again. The sine of 135, remember sine is equal to y, and my y, I have x and y, my y is radical 2 over 2. My cosine of 135 is equal to x, which is radical 2 over 2. And my tangent of 135 is equal to y over x. So I have radical 2 over 2 over radical 2 over 2. And this just cancels out. That's going to be equal to 1. Okay? The only other thing that I have to do is think about this terminal side to decide whether these are going to be positive or negative. So you can see that it's in the second quadrant, because we have quadrant 1, 2, 3, and 4. So referring back to this chart, I can see my sine is going to be positive, my cosine will be negative, and my tangent will be negative. So I have positive, negative, and negative, and that's my final answer. The arc length of a circle intercepted by the central angle is related to the central angle. So the arc length formula is S equals r theta, and that is for a circle of radius r. The arc length S intercepted by the central angle theta, measured in radians, that's important, is given by the following formula. So I would write down this formula, and I would label what every part of it is. Arc length is S, radius is r, and then theta, of course, is theta, but it's measured in radians. That's important. Okay? So it says the arc length S of a circle is a portion of the circumference of the circle. Okay, you should know that if we're talking about this distance, that's part of the circumference. This portion is the ratio between the measure of the central angle and the measure of the entire circle multiplied by the circumference of the circle. So this is saying exactly what this said. This is the measure, the angle measure that we're talking about, over the entire circle, which we've already talked about. An entire rotation is 2 pi times 2 pi r, because 2 pi r is how we find the circumference. You should remember that, or pi times diameter. And then they've just simplified it, because 2 and 2 will cancel, pi and pi will cancel, which leaves you with theta times r. So example 4 says find the arc length of S1 and approximate to the nearest tenth. So I'm going to write down that formula, which was S is equal to r theta. Okay, I'm looking for S sub 1, so I'm going to plug in S sub 1. That's what I'm looking for. My r is my radius. My radius here is 5 centimeters. So I'm going to plug in 5 centimeters. And my angle, my theta, is 2 pi over 3. So I have 2 pi over 3. And now all I have to do is multiply. So when I multiply those, I get S sub 1 equals 5 times 2 is 10 pi over 3 centimeters. and then I can punch out in my calculator. It says approximate to the nearest tenth, so I'm going to plug in 10 times pi, 10 times pi divided by 3, if I can punch it into my calculator correctly. And that gives me approximately 10.5 centimeters. I had 10.47, and I rounded to the nearest tenth. Okay, I want you, I guess I don't. Okay, so same thing here. It wants us to find s of 2 and approximate to the nearest tenth. So I'm going to start by writing my formula. S equals r theta. So I'm looking for s sub 2. So I'm going to plug in s sub 2 equals, my radius here is 2.5 feet. So I'm going to put 2.5 feet. Put that in parentheses. Now my theta, I want it in radians, and right now it's not. So I'm going to have to change this to radians. So if I'm changed from degrees to radians, I take whatever measure I'm talking about, and I multiply it by that pi over 180 degrees. So whenever I do that, I'm just going to, whenever I plug that into my calculator, I would plug it in as 225 divided by 180, and that would go to math, fraction, enter, and that gives me 5/4 for this part. So I have 5 pi over 4. Because they're always going to want it to be exact like that. You don't want to have a decimal. It needs to be that fraction. So if you leave the pi out at first, you can use your calculator to convert it back to the fraction if you don't know what it is. So I have 5 pi over 4. And then all I have to do again is multiply and approximate. So when I multiply, I have 2.5 times 5, which gives me 12.5 pi over 4. So I'm going to take 12.5 times pi and divide it by 4, which gives me approximately 9.8. And we're going to say that's in feet. Last example. Earth makes one complete rotation in 24 hours. Hopefully that's something you already know. And its radius is approximately 3,955 miles. If an object is fixed on Earth's equator, how far does it travel in 1 hour due to Earth's rotation? So they're wanting to know, whenever the Earth rotates and the object started here, in an hour, how far did it travel? So we are wanting to know that arc length. So we're going to take S is equal to r theta, and we know what the radius is, but what we don't know is this theta right now. What we do know is that if the Earth had gone a full rotation, which is in 24 hours, that would give us 2 pi. So I know we're doing 1/24 of that. So to find theta, I'm going to take 1/24 times that full rotation, which is 2 pi, which is going to give me pi over 12. And that's what I'm going to plug in here for my theta. So I have S is equal to, not R, I wanted to plug in there. S is equal to 3,955 times theta, which I said was 12 pi over 12. And then all I have to do is multiply, so I'm going to punch that in my calculator real quick. And that tells me how far does it travel in 1 hour. So it's going to travel approximately 1,035 miles in 1 hour. Okay, so that's all I have for you. You can go back and look at any part of this that you need to. I hope that you've taken some notes while we've gone through this. If you need to go back and take some more, please do so. Your homework assignment for today is Lesson 63, A through H, 1 through 3, 6 through 17, 27, and 30, which is a little random, I know, but picking out some of those good problems for you. This assignment will be due when you walk in the room tomorrow. You will show it to your substitute, who has directions to make sure that you have completed every single problem. So please put forth the effort and do a good job. Please be good. You should not be talking. And you should also be getting a review if you haven't gotten it already. Your tests last week were not pretty, and if you look at your grade checks this afternoon, you will absolutely see what I mean. So I'm going to give you the opportunity to make those up on Friday. We'll talk about that more when I get back on Wednesday. But your review that you're given today should be given today. If you haven't been given it, please ask for it. That is going to be due on Wednesday in addition to tomorrow's lesson. So you have plenty to be working on. Please make sure you're using your time wisely.